Blockchain meets big data, opportunities and challenges. Blockchain, at its core, it is a distributed ledger technology. It records transactions in a decentralized and unchangeable way. Each block in the chain contains a batch of transactions. These are validated through consensus mechanisms. Big data, it refers to the massive volumes of structured and unstructured data. It is generated every second from various sources. These include social media, IoT devices, sensors, and business operations. The main characteristics of big data are the 3 V's: volume, velocity, and variety. Big data technologies aim to store, process, and analyze these data sets. The goal is to uncover actionable insights. Opportunities at the intersection of blockchain and big data. Enhanced data security and privacy. Blockchain is secure for storing big data. Its decentralized, immutable nature makes it so. Traditional data storage systems are vulnerable to cyber attacks. But, blockchain's cryptographic algorithms make unauthorized access very hard. Improved data quality and integrity. Blockchain ensures that data remains tamper-proof, which is critical for maintaining data integrity. In big data, insights rely on data accuracy. Blockchain can be a reliable source of truth. This is particularly useful in industries like finance, healthcare, and supply chain management. Decentralized data marketplaces. Blockchain and big data allow for decentralized data marketplaces. They enable secure buying and selling of data between individuals and organizations. Blockchain makes transactions transparent and respects data ownership. Challenges in integrating blockchain and big data. Scalability issues. Public blockchain networks, like Ethereum, are often criticized for being slow. Processing and validating transactions across multiple nodes can be slow. This makes it hard to handle the high volume and speed of big data. Storage limitations. Storing large datasets on a blockchain is impractical. It is too expensive and blockchains have limited storage. Hybrid solutions that combine on-chain and off-chain storage are emerging. But, they add complexity to the integration process. Energy consumption. Blockchain's consensus mechanisms, particularly proof of work, POW, are energy-intensive. Big data processing needs a lot of computing power. It can then waste energy and hurt sustainability. Complexity of integration. Merging blockchain with existing big data infrastructures requires significant technical expertise and resources. Businesses must invest in hybrid systems. They should combine the best of both technologies without losing performance. High costs. Implementing blockchain and big data solutions is costly. It has high infrastructure, development, and maintenance costs. This can be a barrier for SMEs looking to adopt these technologies. Interoperability issues. Blockchain networks often operate in silos. Achieving interoperability between different chains and big data platforms is a big challenge. Standardization efforts are underway but are far from universal adoption. In conclusion, blockchain and big data are still in their infancy. But, their potential to reshape industries is undeniable. To reap the full benefits, businesses and governments must invest in R&D and education. Collaboration among tech providers, regulators, and academia is vital.